The first speaker this morning is none other than my humble self, and I'll be talking to you today about sugarcane breeding. I would like to start my talk today by highlighting the role of plant breeding in society and how it all began. In today's world, plant breeding can be described as the art and science dealing with the genetic improvements of plants. But I would like to submit to you today that plant breeding is as old as humanity itself and probably started when early man began to have preference in selecting one plant type versus another plant type, for example, fruit size, color, taste, and non-shattering. I have a picture here showing you the different variations that exist in plant type for corn and for sugarcane. Plant breeders use knowledge of genetics to plow their craft. Genetic variability is a very important raw ingredient in every plant breeding program. In today's world, we use control crosses to create genetic variability. That genetic variability is what we use to mold using selection to the plant type that we want. And early man probably did that unknowingly to create the plant types that we do enjoy today. Secondly, selection is the driving force behind any breeding program. We use selection, like I said before, to mold the variability to a form that's beneficial or useful for mankind. When we do select, we select what we see, which is what early man did. But then we get a lot of noise from the environment in our selection program. So what we do is we try to minimize that noise by planting our trials in several reps and several locations. Most traits in sugarcane are controlled by many genes, and the environment has a great influence on what we're able to see. So that's why we do plant our experiments in several locations. Like I said before, during the early times, early man probably selected one plant in preference to another and shift the genes in that population to what was desired. As you can see from this cartoon here, he ended up fixing the genes for his preference. So with each generation, he eliminated the undesirable plants and allowed only the plants that he selected to intermate and form the next generation. He did that unknowingly. And that's what we do today in our breeding programs. Like I said before, again, plant breeding is as much as an art as it is a science. The art comes from the ability to recognize and select the desirable plants. For example, early man probably selected big, juicy, and easy to chew stalks of sugarcane and inadvertently increased the frequency of genes for high sucrose and low fiber in the population. Today, with our knowledge of genetics, we use plant breeding to expedite the process. So in our program, we start by understanding the mating habit of the species in which we're working. We understand the gene action or the genetic control of the traits of interest. We understand the heritability of the trait. If the heritability is high, we select with more confidence. If the heritability is low, we tend to lower our selection pressure during our selection process. With the advent of molecular marker technology and with help of people like Dr. Niranjan, whom I work closely with, we can now select directly for the genotype, G here, without the influence of the environment. For example, he's able to tell me if a parent that I want to use for my crossing program has a rust-resistant gene GRU1, and which of the parents I can use. And when I generate my progeny, he's able to tell me if that progeny has that gene so that I can avoid planting expensive trials to see if that progeny is carrying that gene. We also use scientific knowledge to understand what happened in the past, like you see in this cartoon here, where we can see that the domestication of rice happened in 2 steps, where early man probably selected for the non-shattering gene and for erectness before selecting for grain size. And as if you don't believe me, I know I'm preaching to the choir, the power of genetics has also been used a lot in our modern crop species. As you can see here in corn, the first corn varieties were open pollination. Were created by open pollination. Then came the double cross hybrid, and then the single cross hybrid with the generation of inbred lines. And then came biotechnology in the 90s with a greater understanding of molecular markers, tissue culture. And for example, they were able to inject genes into our plants and grow them out in the field, as you see in this cartoon, with the BT and Roundup technology. So this slide here shows you the power of plant breeding. You can see that each time that we have a deeper understanding of genetics, we tweak the breeding program based on that knowledge, and it increased corn yield in leaps and bounds. In sugarcane, here in Louisiana, we have seen yield increases of about 88 pounds of sugar per acre over the last 50 years. So now that you are convinced that plant breeders are a very important group of people, let me switch gears and tell you about sugarcane breeding. Well, instead of talking to you today about my breeding program, I would like to step backwards and present to you the amazing journey that led to the development of modern cultivated sugarcane. We have ample opportunities during field days for me to talk about my breeding program and the many varieties that we have for you in the pipeline. As you can see here, Sakura officinarum, which is one of the parents of modern cultivated sugarcane, was the first sugarcane that was cultivated all over the world. This variety was probably domesticated in Indonesia and Papua New Guinea, in this area over here. And the cane was found in gardens as far back as 8000 BC. Sakura officinarum probably came from a chance mutation of Sakura robustum. In this area, Sakura robustum is used to build houses, it's used to make fences and to make weapons. So what probably happened, like I said before, this area is considered the center of genetic diversity for Sakura species. And remember, we talked about genetic variability being a raw ingredient in any plant breeding program. So what probably happened was that a vast amount of genetic variability was unleashed by chance fertilization out in the wild, and with the keen sense of smell of animals like pigs and rats, they were able to sense out those with high sucrose, and they started eating it. And the early humans probably, because these animals always came around settlements, the early humans probably saw that and adopted that, and here we ended up with Sakura officinarum as cultivated sugarcane. Let me tell you a little bit about the other relatives of cultivated sugarcane. Like I said before, Sakura officinarum was the first cultivated sugarcane that was sent all over the world. There are no wild forms of this species. It was called noble cane. Sakura spontaneum, Sakura robustum, is found in gardens in Papua New Guinea alongside Sakura officinarum, and is probably a progenitor species of Sakura officinarum. Sakura sinensis was domesticated in China and was probably derived from a cross between Sakura officinarum and Sakura miscanthus. Sakura barbari was domesticated in India and was probably derived from a cross between Sakura officinarum and Erianthus. Sakura edule is an edible inflorescence, and it's eaten in Papua New Guinea, Fiji, and Vanuatu. Saccharum spontaneum is a wild species. It's widely distributed all over Southeast Asia and North Africa. According to Jim Avon, this is the only true species, and he considered all of these a horticultural group. The Saccharum species are a very promiscuous bunch. As you can see here, all of these species can intercross with each other, as well as with non-Saccharum species or genera such as Miscanthus and Erianthus. I put this slide here just to show you how important the Saccharum species are to the cultural life of the people in Papua New Guinea. As far back as 1928, when Dr. Brandis and his team visited New Guinea to look for new disease-resistant varieties on the behest of the USDA, they found big, tall canes used as building material in this area. This slide is from Jeff Hoare. It shows you a Saccharum edule, the edible head of sugarcane. Like I said before, Saccharum officinarum was cultivated all over the world prior to the 1910s, including in the US. It was afflicted by a disease called Sorey disease, probably mosaic, and the breeder started looking for solutions to this problem. Breeders had known for a long time that the wild species Saccharum spontaneum was resistant to pests and diseases and environmental stress and could grow with less nutrient. They also knew that this species was widely distributed in nature from the tropical to subtropical regions of Southeast Asia and North Africa. Let me drink some water here. So here you can see Saccharum spontaneum growing in different types of environment. Saccharum officinarum was considered noble. It was found in gardens. Saccharum spontaneum was considered wild and needed nobilization. So what happened that in the past was that they crossed Saccharum officinarum as the female parent with Saccharum spontaneum as the male parent, and backcrossed it to the high sugar producing parent, and it took just about 3 to 4 generations of backcrossing to achieve high sucrose, mosaic resistance. And this was the sugarcane that was sent all over the world to begin the modern sugarcane breeding program that we do enjoy today in Louisiana. So I'm going to talk to you about the Louisiana success story. Because of the problem of mosaic that we had here in Louisiana in the 1920s, and the fact that our environment is temperate, we continue to use Saccharum spontaneum in our breeding programs. And as you can see from here, the first success story from this program that was started by the USDA in 1964 led to the release of LCP 85-384. LCP 85-384 occupied a great many acreage here in Louisiana, but it was taken out by rust. But LCP 85-384 has been very, very useful in our program, as you can see from this geology that I wrote. It's a proud parent of several of our varieties and a proud grandparent of several more. I'm going to end with this slide to show you some other things that I would like to present in the future. Thank you.